All right, let's go ahead and see if we can take care of this one. Hope you guys are all well. This question came up 3 times so far out of 5 people that have done the homework, so I'm assuming it's going to be a big one. Anyway, so it says let R be the shaded region between the graph of blah, 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 the x-axis, blah, blah, blah. All right, I need to see what this looks like. Set up an expression for the volume of the solid. Okay, so I know this is a volume piece. So I really want to keep in mind, if I can go back to our acronym, then I have at least kind of this systematic way through these problems. It's kind of broken up into chunks for me. So I'm really at this first stage. I want to see what it looks like. And so what I went ahead and did is I made a picture or an image of this. There it is. So you can see we have the curve square root of x plus square root of y equals 2, which is right, here it's the curve. We've got this line x equals 1 right there, and the line y equals 1, or x equals 0, sorry, x equals 0 as well. And what it says we're going to do is we want to take this. Oh, and it says we also want to use the x-axis also. So, this is the other region. And we really want to take this area that's in here. Right? So it's that piece that we want to take. And we want to rotate it around the line x equals 1, which we already had graphed. So this is like our rotational axis. And I want you to think about what that's going to look like if that happens. We're going to get kind of this solid that looks something like this, But then it's going to have kind of this bowl cut out from the inside, and maybe it's a little pointier right here in that center, because this is kind of pointy to me right in here. But we're going to get something that looks like that. So I now have a picture. I kind of see it, kind of visualize the solid. And so I need to know what the rectangles are or the radius in this instance. Keep in mind, when we want to slice this, we want those slices to be consistent, and those slices need to involve the radius. So if I slice it the way the black lines are, I'm going to get these slices that really look like circles. Whereas if I were to slice it in a different way, like the green, I'm going to get these really weird kind of, think about taking a can and slicing it from the top down. They're just going to be really weird slices, and they're not going to be consistently shaped. Well, I guess they'd be weird rectangles, but we really don't know a lot about those. Whereas the circles, I do. So that's what I'm going to go for. I'm going to slice it this way, which means, probably should be on the black still. I'm going to slice it this way, which means that this is really going to be my rectangle or my radius. Now the weird thing is, when I slice it down there, I'm going to get a solid circle. But when I slice it up here, I'm going to get this circle, but it's going to have a hole in the middle of it. Whereas like the bottom slice, I'm just going to get this solid circle. And so it almost seems like I'm going to have to split this up. So the question becomes, where? Well, this rectangle that I have drawn down here, that's going to make a solid circle. But as soon as I get above there, as soon as I get it right above that spot, I'm going to get, something that would have been solid, but now it's missing, a part. It has a hole inside of it. And so I'm going to come over here, and that's that green hole. And then this is the outside piece. You see right there. So at this point, I know what the image looks like. I've drawn some of my rectangles, and I know what my slices look like, which is great. But I really need to know, like, so about those slices, I need to be able to find the area, which means I need to know kind of those rectangles. I need to know what the radiuses are. So let's go ahead and just focus on the black one, that solid slice. Well, I know that the radius really goes from this axis of rotation back here to the y-axis, or x equals 0 line. And so that radius is pretty consistent. It's 1. The radius is always 1. That's just going to be a solid cylinder. That's not a big deal. As a matter of fact, I can go ahead and figure out the volume of that solid cylinder. I mean, if you think about it, we're going to get this solid cylinder here. And if you think about what we know about it, we know that the radius is 1. We also know that the height of that cylinder is 1. And I know that because, coming up to that blue dot right there, that's 1. So the height of that cylinder is 1, the radius is 1. I know that the volume of any kind of cylindrical shape or some prism shape, because that's really what a cylinder is, it's a circular prism. You're going to take the area of the base, which is pi r squared because it's a circle, and then you're just going to kind of build those slices up. So if you think about it, it's like a circle and 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 a circle. That's that idea of integration there. So you're going to multiply that by the height. So that's the volume. Volume of our cylinder there. And so really, if you think about that black piece on the bottom, the volume is going to be pi r squared, which is really just, that was supposed to be a 1. I don't really like writing on electronic devices. And then multiplied by 1. So it's really just going to be pi, which is great. But that top half is going to be harder, right? So, maybe I want to make this a little bit bigger, right? So that top half, maybe I make it a little bit bigger. So we can really kind of focus in on what's going on there. So I've got my blue circle, and then I've got my green circle, which is a hole in the middle. So I really want to know about the size of these. So I'm wondering, like, the blue one, what's the radius? And if you come over here, that rectangular radius we have drawn, that's still 1, right? Like, that's still going from that center or axis of rotation all the way out. And then that inside radius really goes from this line 1 back to the curve. And this is really interesting. So what I need to know is what's the x distance there, right? Because it's going along the x-axis. So I need to know how long in terms of the x it is. So I know that this is at x equals 1. So I'm wondering, sorry, my stuff moved on me. I gotta move it back. If that line's at x equals 1, what's this spot back here? Where's that in terms of x? So I want an x equals for this. So that's really coming from this curve there. And I want to get it so it says x equals, because I'm trying to figure out the distance and the x values. So, if I solve it for x, I could get root of x equals 2 minus the root of y. And then I could square both sides, so I get x equals 2, subtract the root of y squared. So really, again, keep in mind what that is that's this spot right there, okay? We're really trying to figure out how far that is. So I'm going to do this just so we can kind of see a little bit better. So I've got this big long radius here. And then we've got that green radius, which is going from that x equals 1 spot back to this other x spot back here. And so keep in mind, so I'm looking for the length of that radius. We've got that acronym DID, right? So distance is difference. So if I just want to know that distance, I really want to take 1 and I'm going to subtract the other x value, which the other x value is this right here, right? So I'm going to subtract that because that's the x value. And I'm trying to find how far apart my x values are. So that's my, wait, what is that? Oh, that's the green radius, right? That's this radius right here. All right, cool. So now if I want to think about this, right, I need the area of this big slice. So the area of this big slice is really going to be, let's see, pi r squared. We'll just go 1 so we don't get confused. But then we need to take away the other one, the green circle, right? So it's going to be subtract pi multiplied by 1 minus 2 subtract the root of y. Parentheses are important here, right? All that squared. All right. So, you know, maybe I need to get this a little bit bigger here, right? So we can all see this. I apologize. So we've got pi, because that's really the pi times 1 squared. And we're subtracting pi multiplied by 1 subtract 2 minus the root of y squared. Oh, okay. So that's the area of this like blue cross section that's missing the green hole in it. So now I know what the area is, right? So if I go back in my acronym, I have the area. Now I need to turn this into a volume. Well, keep in mind this is a circular disc, right? But it's not really a circle. It has a little bit of thickness to it. Matter of fact, if you look over here, you can see the thickness. It's got like a dy thickness to it. So if we take the whole thing, and I'm going to get rid of this circle, so we can start to see, you know, don't have as much whiteboard space. Lost my square there. If we take this whole area, and we multiply it by that thickness, I now have it so it's actually a volume. So I now have my volume. And then what I want to do is I want to integrate this because I want to add up all these slices, right? Like I've got a slice here and a slice here and a slice here. I want to add up all those slices. So we're going to integrate this thing from, well, where? Well, where did these slices start? So if you look, I already got this stuff with a black one down here, right? So where did these other slices start? They started really right there, right? And where are they going to end? Well, that's a great question. Where are they going to end? So they're going to start at 1, and I'm going to keep slicing and slice and slice and slice and slice until this curve actually touches the y-axis. Where does that curve touch the y-axis? Okay, so if you think about it, as soon as the y value is 4, the square root of 4 equals 2. So I'm like looking up here, right? So I know it's actually going to touch at 4. And that, right there, is going to be the volume for my top half. So I'm really going to have this volume, the one that we just found. So I'm going to have this, because that's my top half. And then I also have my bottom half, which we had found earlier was just pi. And so I can just add those together. Now keep in mind this is a calculator-based question, so I can type this all in and just go ahead and find my value. Hopefully this helps. I will see you guys all soon, hopefully. Take care of yourselves. Stay healthy.